Is going to be a exercise in taking an existing setup and improving it using your knowledge of MONAI. So the objective here is we're going to be given images in MR of the heart, and we're going to segment the left ventricle. So I'll just go through the notebook just very briefly, and then I'm going to set you off on your merry ways to do it yourselves. But just do our usual imports here. If we look at what the actual data is, what we have, if I zoom in a little bit, is going to be this kind of image where we're going to have a MR background, and then overlaid is a separate segmentation image. So you can see here that we have what is an annulus around the left ventricle of the heart, and you can see the bright chambers around it, and then other tissue, there's the lungs and things of that sort around this image. So this is what the training set is going to look like. And we're going to partition it very simply just to keep 6 cases for a testing set. We have a very basic series of transforms here. We're using array data set and then just basic data loaders for the training and validation data. We have a very simple network here. And again, this is very PyTorch. There's nothing actually, I think, particular to MONAI that we've introduced here. And then we go through the usual training loop, where that once again is essentially just a PyTorch training sequence. So because our images are not terribly large, we can throw them in relatively large batches directly into the network and train with that. And we do our validation at the end of each epoch. And then looking at what our results are, as you can see for validation, things sort of stall out at a pretty low number, and they jump all over the place and don't get any better after a while. So what we are going to have you to do is to get this to do a lot better. So it's up to you, now that you know quite a bit about MONAI, to figure out how to go about solving this problem for yourself. So this is going to be an exercise in figuring out this problem, and you're perfectly free to use whatever you like. There's no reward for this particular challenge other than a good pat on the back virtually through Zoom, if that's really what you want. But this is going to be a good warm-up, I think, for the day 3 challenge for the people who can, who will be able to participate with that. So with that, we're going to set you loose on this. And if there's any questions you would like to ask me now, this is the time. Of course, we'll still be here on the Slack as usual. So anyone, any questions, feel free to unmute yourself. I did update this just a few moments ago, so you might want to bring that down once again. So the major changes that were done here, of course, were we wanted to add a few more actual augmentations here to what was going on. So I've done a number of changes here. We're using dictionaries for one. So we have just a single sequence of transforms as part of our training pipeline. What we've added to this is random rotate 9 degrees, random flip, random zoom. With a zoom, we're using particularly nearest neighbor interpolation. And with the random 2D elastic deforms, we're using 2 different modes, essentially. We're using the bilinear for the images and nearest for the segmentations. So this will give us output such that the segmentations will have still integer values, and they won't be sort of rounded, blurred edges to them. It just maintains the clear edges that we want, followed by some random affine transforms, which is going to do rotation and translation for us. And again, the mode here is going to be bilinear for the image and nearest for the segmentations. We're also going to use a cache data set instead of the array data set we had there. There's really no way of combining the two, and because we're using dictionaries here, there's really no need to be using it. So the solution was to do it this way, where we convert our sequence of values into a sequence of dictionaries, and then use our cache data set to cache the first 2 operations. That does give us some speed up, so it is worthwhile to do that. We then have the validation transform, which I've just left alone. So this is still using array data set. That's not changed. And as you can see, there's some results here. So as you see, there's a lot of stray pixels and extra pixels in the segmentation. So some of the elastic deformation isn't always going to be a good thing, but it looks odd in some examples like this, but it does add that sort of randomness to the training set that is still useful for learning from. So as for our networks, I just commented out what I originally had provided, and I just went to go use a UNet as provided by MONAI. So we're in 2 dimensions. We have a single input and single output channel, as we expect from the images. And this is a 5-layer UNet. So we're going to have 4 downsampling layers, and then we're going to have a bottleneck layer with 128 output channels. And we're using a stride of 2. So every layer is going to downsample the input image by a factor of 2 in each spatial dimension, and then pass that along to the next sequence. We're not using residual units in this case, but that's something you could possibly do. I am using a little bit of dropout here just to add a little bit more randomness so that we are regularizing a little bit better. The rest of this training loop is the same, so that's unchanged. And then when we look at the results, it's still topping out at, say, 0.7, but just much better than what we were getting before, which is like somewhere around 0.2 something or other. So we're getting quite a bit better results by adding our randomization and by adding a little bit more regularization through dropout. So let me just rerun this. So one of the things with the actual loss over time is, as you can see, it has this sort of stair-stepping thing where it will go down and jump back up when at the end of an epoch, when we restart again from the beginning of our sequence of input values. So it's perhaps not the most ideal way of training, and so thinking about a better way of doing that, where we have randomly sampled mini batches instead of going through each value in our training set as a single epoch, instead doing things with iterations of randomly chosen values for a set number of times to compose an epoch. But that's something I leave as an exercise for later. So that's these solutions, and that's really mostly what I changed. What we wanted you to really do is get a hold of how to use the networks and how to use our transforms together. We could also turn this training loop into something that's going to use our workflow types. However, it really shouldn't make a big difference in terms of results you get out of it. It would just be a lot less code for you to deal with. So that's my solution, at least. Of course, there are many other solutions. If there's any questions, you can go ahead and unmute yourself if you like.